Hello?
Hello.
All right, good. Okay, so yay. All right, so now I gotta open up the blinds. All right, so now I asked you guys, or yesterday we actually did a whole bunch of calculator stuff. Okay, so for this problem right here, I'm kind of going to go through this kind of quick so you guys can see what's going on. But I would like for you guys to start this out. I want you guys to go to your graph. Go to your graph in the calculator. And go ahead and enter that function. So this table is slightly different. Because it doesn't tell you what numbers to put, right? It doesn't tell you what numbers to put. So that's the point where I'm trying to make. So when you're doing it yourself, you're not going to have blanks to fill in. You're going to have to actually think about the type of things that I'm going to enter, right? So as I enter this in my first function, right? Yes. Okay, so I enter it in my first function. Ooh, crap. I got to fix something real quick. So I'm going to show you guys how to fix it because I just remembered my other class was doing something different yesterday. So, documents. Okay, let me go tools, prepare handheld. Okay, so I'm going to show you guys this later too. Crap, it's over here. Everyone, take a look in the top right-hand corner of your calculator. What does it say? Degrees. And what did I say at the beginning?
Radians.
Radians. So I'm going to try and set your guys right now, everyone's settings. Okay, I'm going to change that right now for you guys. Everyone popped up that, did everyone pop up that transferred? Anyone not? Anyone not change the degrees now?
Change 2 degrees?
Did anyone not get changed? Are you in radian now?
Yeah.
It says rad? Okay, all right. You're still there? Okay, so I'm going to show you now. Here, watch. So you're going to go house. Okay, I'm going to go settings, which is 5. Document settings 2. Okay, and I'm going to go change this to radian. And then from here you make default. So it's going to change all your stuff to radian now. Click OK. There we go. So now it should say rad again, right? Fonzie?
It's just showing like a loading thing.
Okay, so it's coming up then. All right. Okay, so now that you guys have this in the function, right? You have it in the function, so I'm going to go through and let's take a look at it. I'm trying to find the limit as it goes to what? 0. I'm trying to find the limit as it goes to 0, right? So can I plug in 0?
No.
Say no.
No.
I cannot plug in 0. Why?
0 denominator.
Yes. Okay, so if you have something weird pop up like that, do this. Dot, letter B. It fixes everything. Okay? Resets it, okay? Alright, so it's a no. So this right here, okay, I'm going to tell you, it's interesting, okay? But there's some stuff that we're going to do later on which is going to make this work, and it's going to be so much easier. But like, crap, why didn't we do that at the beginning of the year? I'm like, Anyway, all right, so we know we're not plugging in 0, right? Say yes.
Yes.
Okay, so if we're not plugging in 0, we should have 0 somewhere in between, but then we're going to find numbers for this. So let's say the left side of 0. What should I have on the left side of 0?
Top or bottom?
Give me a number that is on the left side of 0, which is going to approach 0.
Oh, yeah.
Come on, you guys. Come on. I know it's early in the morning. -1. But now, let's get it closer because it's going to be approaching, right? Okay, so let's go negative. No. All right, there. Okay, there. So it's negative point, 0.1 or negative 0.01 or negative 0.001? Yes? Okay, so now how about the right side? What are the numbers on the right side?
0.1.
Okay, so do the same thing, right? Okay, do the same thing. So I like it approaching in the middle so I could actually see what it's going to. So I'm going to fill in here. So I'm going to say 0.1. I'm going to go 0.01 and 0.001. So right in between here, we're going to get some nice answer. Okay, don't forget, the vars makes it pretty easy. So as you entered it in there, you go to vars and you start entering in your numbers. All right, using this, what are we coming up with? Are we having trouble back there? Oh, okay, so.
So I'm gonna go trade right here, sine x, close over x, enter. Okay, so we're gonna start doing this. Okay. So let me see if I can actually do this to help you out. No? Okay, so I can't read it, so I'll let you pick it. Yeah, I think it's at the bottom. Keep going. Is that the bottom? No, it's not? Oh, I thought it was. Okay, I can't read or speak or, dang. There's not, no. Okay, I'll download it for you, okay? So I know I could update it and actually have it, so as of right now, go ahead, try it, keep going, okay? And I will download it for you. So now we're back here, right? Okay, so now you do the bars. So there's my function where I just entered that, right? And I go negative 0.1. Okay, all right, there you go. Yes? Because it keeps approaching it, right? So yes. So the calculator's rounding it off because it's getting so close, right? So we're getting closer and closer to 1. So on your guys' calculators, because it starts rounding off at a certain point, you see the number actually keep going up, right? So once we get close enough, the calculator will automatically round it to 1. So we can see what's happening there. So let's take a look. Let me see, next one. Okay, so now we're just going to be looking at the graphs. So you can go back to the graph of that function that we just had there, and it's going to look like, oh, it's on that other screen. It's going to look like this, right? So here I can clearly see that my graph is approaching 1, right? But given a graph, can you really say that's going to be 1? Just by looking at it. It looks like 1, but it might be 1.02 or something like that. So you really can't say definitely. You could evaluate it to actually solve to see what it would be there. Okay, but since I cannot say what it is, because could we plug in 0 for this? Say no. That's going to be undefined. There's my hole. So, but the left side here and the right side here both go to that number. And that's what I'm trying to get at. So the left side and right side both approach that number. So the limit, so as it's approaching this, it's going to be 1. Okay, all right. So, now, using the graph, okay, so it says, notice in these figures right here, I have these 3 here. Okay, so this one, there is a solid dot there. You can kind of see it, right? Solid dot, that means that number exists. So that means the left hand and right hand are both going to that solid dot, and I can plug in that number. That number does exist. For that C value, yeah, for that C value, it is going to exist. So that's just plugging it in. On the second one right here, the C value has a open dot. So that means that it is non-existent at that point, but it is up here. So this is a piecewise function. So a piecewise function where it does not exist here, but it still exists here. So if I were to plug in an X value, or in this case I would plug in my C for whatever it is, I will get a number out of it. But will it be the limit of the function? No, because it's way up here. The limit needs this right here. The limit needs that point right there. Okay, so that's the reason why it's going to be different. Okay, and on this one right here, it does not exist at all. At all. And so the left side and right side both go to that open dot. So that is my hole. Okay, there is nothing going to be there, but both left and right need to approach that. All right, use a graph to investigate this right here. I'm going to show you guys how to enter this in your calculator. So we're going to go to the graph. So helpful hints. Okay, so all the stuff that I'm actually talking to you guys about on these graphs and all this calculator stuff, you know, make yourself a note on it if you can't remember. If you're like really forgetful about things, so make yourself a note on certain things. So now we need to change this function. So to change this function, I hit tab, and it will bring up right here. So it asks me if I want a second function. That's F2. If I want to change the function that's already in there, I arrow up, and there's that function. Hit delete. Okay, so now let's take a look at, it was a piecewise 3x plus 1. So now, right here, there is a book. Right where my mouse is at over here, right next below this red button, there is a book, and to the left of that book. Okay, if you can't find something, hit the book. That's your whole catalog. That is everything that the calculator can do. But to the left of the book is their operators. These are your mathematical operators that you're going to use. So I'm going to hit that, and I'm going to have a piecewise function. So my piecewise function is this right here. So this is a piecewise function with just 2 in it. Okay, 2 different equations in it. Okay, if there is more, then I will have to use this one over here, and then I could add, 4 or 5 different functions, different parts of this. So I'm going to hit this right there, and my function was what? 3x plus, okay, x plus 1. Okay, arrow over, and now it's going to ask for the restrictions on this one right here. So what is my restrictions here? X. All right, so now I got to show you where this button is. Okay, right here below control, there's an equal sign. Below the control, there's an equal sign. Hit, if you look, mine's blue. I think yours is yellow. So right above it, it has other symbols. So it's going to bring up a little menu. So you're going to hit Control, equal, and then it's going to give you the other options besides equals. So this one's going to be not equal to, right? So not equal to 2. Okay, let's go down to the next one. And the X one is what?
10.
It says 10?
Yeah.
That's it, just 10, right? And then it's going to be, so X equals 2. So there's my piecewise function. Now I go ahead, hit enter. So you're going to have a lot of functions like this. Does it look like it exists at 2?
Yes.
So I'm going to zoom out right here. So it looks like it exists at 2, right? But does it? No. So this is the key. There we go. It should be right about here. I don't know. What is this? Anyway. So I could actually figure it out. I could say, oh, hey, let's plug in to see what it's going to be. So I could look. Okay, what is it going to be? Now watch this. This is a neat trick for this calculator. Okay, so I'm going to do menu. I'm going to trace. And so it gives me all this right here, a bunch of different stuff. And now, instead of actually doing all kinds of weird stuff or trying to find it on the little slider thing, just hit the number 2. Because once you actually turn it on, you can just hit the number and it'll say that X equals 2. Enter. It says 210. Is that on my line? No, it is not on the line. I see too far. So let me try that again. So I'll do it again so you guys can see it. Menu, trace, graph, okay, and then there's 2, 10 right there. So when X is 2, it's 10. It's not on my line. So this type of function, we would find the limit as it approaches from the left hand and right hand side. Yes? Okay. So the limit is 2. Is it? Say no. No. As X approaches 2, what is the Y value? Nope. As it approaches, remember, if you're doing the limit, what does the left and right side go to?
Because
It's on the line, right?
yeah.
It's on the line. So let me show you again. This goes back to this previous one right here. So the left side and right side both have to go to this. This is my limit here. This is what the function is equal to, right? Right here, this is where the function is equal to. So if I'm asking for the limit of the function, I'm looking for this answer.
Yes, I need 2, right?
Nope. Someone help him out.
7.
7.
Oh, wait, because X one. Okay.
Yeah, so right here it's going to 7, right? At 2, it's going to 7, both left hand and right hand. So it's basically, I could just look at it here. And usually when you see something like this, it would be some domain restriction where it's going to be undefined there. Okay, but in this one, this is just a basic, so I can plug in 2 there. 3 times 2 is 6, plus 1 is 7. So it's going to be 7, but in this piecewise function, it's not existent there. So left side and right side are both approaching 7. But for the piecewise, it is not. Okay? Did I clear that up? Anyone questions over that? Yes?
So to find the limit, you would just plug it into the piecewise?
Yeah, I would plug it into the first one. Okay, define what the limit is. Okay, so if I had a nice perfect graph with all the dots and everything, I would actually look at it and see, oh hey, look, okay, where it's supposed to be approaching there. Okay, so that's why I would go along with that, because you can't just plug in, okay, because there's a hole right there in my function. All right. Let's see, what do I got next? Okay, right here, piecewise defined, and the function right here, that's what we had. So there was my hole right here, right? There's the hole, and here's where my function actually exists at. So the left side is going to this, the right side is going to this, so it's both approaching that number, and that would be the limit. So if I was asking for the limit, it's 7. If I was asking for f of 2, that's 10. Does that make sense? It's asking for two distinct different things. Questions? All right. All right, so I want you guys graph this one right now with that information I gave you. So you guys want to see what it is from the left hand and from the right hand. All right, you guys should have that graph by now. Let's take a look. Now, looking at it graphically, now, from the left side, what is the limit from the left side? 0. What is the limit from the right side? 1. Now, if you guys go back to the definition I gave you guys yesterday, for the limit to exist, okay, limit to exist, what has to happen?
It must be approaching the same point.
Excellent, that's exactly right. They both have to be approaching the same point. So this one has a conditional validity. So from the left side of 0, it is going to be 0. From the right side of 0, it is 1. But I cannot say that the limit exists at 0. So for this answer, I would say the limit does not exist. The limit does not exist because this is a jump right here. For the limit to exist, both left hand and right hand need to approach the same point. Okay, so here it is right here. For this to work, the limit of the function, okay, goes to C for this if and only if. That means that it has to be both of these. That the left side is equal to the right side. So the limit from the left is equal to the limit to the right, and that's when the limit exists. All right. Let me see, one-sided limits. Okay, so I want you guys thinking about this. We're not going to do this on the calculator. I want you guys to actually think. Now, can I do the limit as x goes to 1 here? You say yes?
Hold up.
Okay, let's start with the left. What numbers are on the left of 1? No. Smaller. Think smaller. Smaller. Like really close to 1. Let's say 0.9. Okay, 0.9. This is why I say that. 0.9. That is approaching, right, from the left, 0.9. If I were to think about this, think of what happens if I put in 0.9. What do I get there? I get a negative. Can I have a negative inside a radical? No. So that means this one will not exist, right? The left side does not exist. Can I do it from the right side? So think of a number on the right side of this, 1.1. 1.1 would give me 0.1. Is that allowed? Yes, that is allowed. So that one does exist. So remember what my rule says. It was if and only if. So that means that both of them had to be true and go to the same number for the limit to exist. This one I would say that the limit does not exist because only the right hand works. Okay? Dang it. I don't know why I'm not using the thingy. Okay, so this one is use a graph. So let's graph that one right there. You're going to get something pretty. Tab. Up. Control. Divide. Sign. Dang it. Put it outside. Control. Divide. There it goes. And what was my value? Pi over x squared. So pi is on a couple places in the calculator. The bottom left, there is a pi button. Or if you want to find it in the catalog, it also does it. Yes, my dude?
It hasn't got ratings.
Are you in the graph?
Yes.
The graph doesn't say radians?
No.
Okay, give me 1 second. I will go there. X squared. Wow. Okay, so
It's fine.
you're just being a pain. Why don't you grab another one? Actually, I think I got one here. Yeah, this one should be fine. All right. All right. So, does that look like it's a nice, pretty one? Say no. No, that doesn't look nice, does it? So can you tell me what it's going to? Not really. All right. So let's see what I get then. Zoom in. Can you tell now? Can you tell now? Can you tell where it's going to now? What about now? How about now? Can you hear me now? Now? No. What about there? Nope. This is a special kind of function. Okay? The more that you zoom in, the more you're going to see it doing this. It's oscillating. It's oscillating. It's going up and down over and over again. The closer you go in, the more you're just going to see that. The more it's just oscillating. So this one right here would be the limit does not exist for the reason of that this is oscillating. It's not going to a single number. So the more that I zoom in, the more it looks just crazy. So if I looked at it and zoomed in continuously on something, I should be getting a number. I should see that the graph is going to something. Okay, but in this case, it's just getting more chaotic the closer I get. So the reason that this limit does not exist is because it is oscillating. Okay, so that's what we got. All right. So these ones are some of your questions that you have at the end of your assignment. Okay, these are some of them. So I'm going to go over this one just so you can see the type of AP questions you're going to see. So investigate, it says, okay, investigate the limit as x approaches -1. Okay, so I'm sorry, 1 from the left. Okay, so what would be 1 from the left from that first one? Okay, so that would be 0.9, right? So that would give me what number? A positive number, okay. So that would be a positive, okay, yeah. Okay, so that would be okay, right? Okay, so, and evaluate as the function, okay, does this right here by choosing one of these. Okay, so can I plug in 1?
Yes.
Okay, can I have square root of 0? Yeah. Okay, square root of 0 just gives me 0. So that I could do that, okay? So right here, okay, using close to 0, slightly less than 0, and would I say this? Say no. No, because what numbers do I need to do close to? Close to 1, right? Because I'm taking the limit as 1. Okay, these are the type of questions you have to read through carefully. Okay, as it, okay, only numbers slightly less than 1. Okay, let's see, only numbers slightly greater than 1. Do I do anything greater than 1? No, this is the one-sided limit, isn't it? Okay, look at numbers close to 1, some slightly less than 1, and some slightly greater than 1. If I said no on the greater than 1 here, would I do some less than and more than?
No.
No. So the only logical answer on this one would be B. That's what you guys are going to have to do. It's not just look, oh, there's the answer. You guys need to read through every one of the questions because quite possibly, you know what, you need to eliminate answers here too. This is an AP question. Okay, reading through the question carefully is part of the technique of doing well on the AP exam. Okay? All right, so, dang it, I wanted to give you guys more time. How about this? I'll give you guys time tomorrow in class. So after our warm-up, we will take time,